Hi Jacob, my apologies. You handed in 3 assignments this week and I marked one, and I guess I meant to go back to the other 2 and forgot, and just found them there in the Dropbox. So I'm sorry for taking so long to get back to you on those. Um, I've got your assignment solutions for your trig identities assignment here, and I wanted to just talk to you about a couple of questions. One of them is 1B. I think I know what you're trying to do here. Sorry, here. I think what you're kind of trying to say is 1 minus sine squared x equals cos squared x. Therefore, you can cross out a cos x on the top with one of your cos squared x's on the bottom, and like that, so that you end up with sine x over cos x, because that's what you've got on your next line. That's true, and you're right, but I think it leaves too much to the imagination of the person who's reading this, if they didn't understand what you were going for there. It looks like you're trying to cross out a cos x with a sine x, and that's not allowed. So just make sure that you include all your steps. I think I know what you meant there. So on page 2, I'm looking at question 2. And sorry, I've made a line there that I didn't want. I'm just looking here to see which one. This one looks good. The first one looks good. Everything that you've got there is right. And your question is, does that mean that they are equal because the denominators are in different order? Yes. 2 times 3 is 3 times 2, same thing. So you're fine as long as you're just multiplying there. They mean the same thing. So that one's just fine. For the second one, it's a little bit of a different way to get there, but you got there, and so you did a great job on that one too. That looks great. So just over to the last page here, and you wrote me a little note saying that you're not sure on this one what to do. So I think what you're missing here is one of the identities, and that identity is that the sine of x plus y is equal to the sine of x cos of y plus sine y, and I'm going to run out of room, cos x. That's what this is equal to. So if you split that up into this identity, then I think you're going to be able to work with it. The other mistake that you made over here on the left-hand side is that when you're finding your common denominator for these guys, then you need to multiply the numerators by the same thing. So on the top you should have a sine y times sine x times cos y. So here we need to add in the sine x, and here we need to multiply in the cos y also. And so you didn't have the same thing on either side because you had made a mistake on both sides of the equation. If you start there, I think that by taking this up and finding a common denominator between the 1 and the second term, and using this identity on the right-hand side, that you can get those two sides equal to each other. And please work it all the way down so that you've got both sides, left side and right side, showing the same thing. So for D, again, this is a good approach. That's a really good way to do it. And if you multiply those things out, then what you get left with, and again, be careful on how you show this. If you've got cos of 2x, then write this as cos squared of 2x, not cos of 2x squared. And then you can cross out a cos of 2x with the squared and just have the cos of 2x left on the bottom. You got to the right place at the bottom. It's just your form is a little scary, and you've got to watch that because you'll lose marks for that in university. So when we're at that point, I think that you've got it solved and you've shown that those two things are equal, so everything's fine. Just be careful about the form, okay?